Hello, everyone. So today we're going to look at the adaptive immunity response, focusing mostly on our B lymphocytes, or our B cells. Just really fast, just to give us an overview of where we are. We looked at the innate immunity. Remember, we're born with that, but that has our neutrophils, eosinophils, basophils, but most importantly, neutrophils and our natural killer cells and our macrophages. Those three are the ones that we talk about the most with the immune system. Now, the response to that can be within hours, right? We're born with these inside of our system. They monitor how we're doing on a daily basis, and they can get rid of minor bacterial infections, minor viral infections that don't really pose much of a threat to our body. But when we have a serious bacterial infection or a virus that gets into our body, we have what's called our adaptive immunity, and that's what we're going to focus on. Now, the adaptive immunity is a stronger response, but it takes longer for it to actually kick in. And that's what we're really going to focus on is the timing here, and then how those B lymphocytes really work, what they produce. Okay. So just a quick little review of what we covered last lecture. Remember, all of our lymphocytes are made in our bone marrow. If it's a T cell, it's going to go to our thymus and become immunocompetent. If it's a B cell, it's going to stay in our bone marrow and become immunocompetent, which just means it matures and it's starting to get ready to be able to do its job when it comes in contact with a foreign antigen. Okay, they are both then put into our bloodstream, and they find their way to our spleen or our lymph nodes, where then they will come in contact with, let's say, a foreign antigen, and then they will be able to do their job, which we will talk about. So today we're going to look at the B lymphocytes, or the B cells. Now, B cells, once again, made in the bone marrow, they are then become immunocompetent there, and then they are released into our bloodstream, and they find their way into the lymph nodes or our spleen. Now, these naive B cells will start to produce what are called plasma cells. These plasma cells are what are most important to making our antibodies, and I'll just briefly talk about the antibodies after we get through a little bit of the information. These plasma cells make tons and tons of antibodies. These antibodies are those Y-shaped figures that we saw in previous lectures, and they are going to attach to the cell's antigens and hopefully shut them down. Okay, we're also going to produce what are called memory B cells. Now, memory cells are important because the next time we come in contact with that same bacterial infection, we'll be able to respond a lot faster. So the first time you come in contact with one of these bacteria that we can't really handle, it takes about 3 to 6 days. So by the time you start feeling sick from something, that might take a day or 2 days, your B cells are starting to mount an attack, but they won't be ready for maybe another day or 2 or 3. That's why when you get sick, it sometimes takes a couple days to get rid of. Okay. The next time we come in contact with that same antigen, right? It's the same bacterial infection. What's going to happen is it's going to be a lot faster. Right? So let's say on day 1 or 2, let's say day 1, you're exposed to the A antigen, right? Some type of bacterial infection that has never been inside of your system. It's going to take 3 to 6 days to start to produce these antibodies. And then hopefully sooner rather than later, you start to feel better. Okay. Now, after that bacteria is gone, it's going to die back down. But what we're going to have is a memory for that A antigen. So the next time we're exposed, let's say to antigen A, the next time we're exposed, we have such a fast response because we already have the memory to that. So we have the memory B cells that can start shooting out all of these antibodies immediately, and we won't get sick from it. Now, simultaneously, for this example, we're exposed to the B, some type of B antigen. That is now going to take us 3 to 6 days to start producing our B antibodies right here. So on day 28, 29, we're exposed to both the A antigen and the B antigen. This is an example. These are just for formality. This new B antigen is going to take anywhere from 3 to 6 days to start producing B cells to then mount an attack against it. Okay. So when we look at the B cells, this is just in review from the last, from the initial slide. Here is our antigen that we're coming in contact. Here's one of our naive B cells right here. This is a B cell right here. Okay. Now it's going to start going through a cloning phase where it's going to start to produce memory cells. So the next time we get sick from it, it won't have such a large impact on our body. And we're also going to be producing these plasma cells that start kicking out these little Y-shaped antibodies. Now, you might say, well, what do these antibodies really do? Well, they do a couple different things, but the two main methods of killing off a bacteria is what we call neutralization and agglutination. Now, neutralization, it's exactly what the word means. It neutralizes it, so it doesn't allow it to bind to any of our cells to either kill them or cause harm to them. So it's going to block their receptor sites. So here, so it should be linking up with this little pink piece on one of our cells, but we block it. The antibody attaches to the outside of that bacteria, and it can no longer do what it needs to be, what needs to be done. Okay. It can also cause agglutination, which just means to clump together. And when it clumps together, that makes it so much easier for one macrophage to come in and swallow that whole thing up. So rather than having individual bacteria floating around, we clump them together. And then when a macrophage gets there, it can eat up 5, 10, 20, 30 of them all in one shot, rather than have to keep hunting them down. So it's an easier way to destroy them. Okay.